And also I'm preparing on lead code and Pramp angry gigs for geeks, I think. Yeah.
Okay, great.
uh,
So, okay, let's start now. Would you like to
which
start
one?
with my question or your question?
I think this is my question, so you are the interviewer right now.
Okay,
Okay.
okay. So you have an array which contains a unique non-negative numbers, all so unique and non-negative. You should find the smallest non-negative integer that is not in the array. So, for example, if the array contains 0, 1, 2, 3, like example here, the output will be 4.
Okay. By the way, I'm gonna use C++.
Yeah, sure.
So 0, 1, 2, 3. I will. The output is 4. Based on what? Sorry.
Based that they are the 4 is not in the array, and it is the smallest minimum outside the array.
Okay. I think I got your point. Uh,
Yeah.
I'm gonna read the problem quickly.
Okay.
Given an array of unique non-negative integers, implement a function get different numbers that finds the smallest non-negative integer that is not in the array.
Yes.
Okay, even if your programming language of choice doesn't have the restriction like Python, assume the maximum value an integer can have is maximum int. Okay, so for instances, the operation maximum int plus 1 would be undefined in your case. Your algorithm should be efficient both from a time and space complexity. Solve first for the case when you are not allowed to modify the input array. You are not allowed to modify the array and still have time. See if you come up with an algorithm with improved space complexity. When modifying array is allowed, do so without trading off the time complexity. Analyze the time. Negative. Okay. Mm. So in the example here, I have 0, 1, 2, 3. So for example, if I have like 1, 2, 3, the output here will be 0.
Yeah. True.
Okay. Uh, okay. And the output is always valid.
What do you mean by valid?
I mean, so every time there will be an input, an output I can return.
Yeah, yeah, yeah. Yeah, sure. I mean, your only edge case would be if the list is empty. That means that the minimum will be 0.
Yep.
So yeah,
Okay. So if the list is empty, here is the output will be 0.
yes.
Okay. Hmm. I'm gonna think of the brute force solution first. Is the array sorted?
No, it's unique and non-negative. Just that's all.
Okay, so the array is not sorted.
Yes.
Okay. Mm. So for example, if I have like 4, 3, 5, 8, the output here would be 0.
0 also. Yes.
Okay, so if I have like 0, 1, and here the output is 2.
Exactly. Yeah. Correct.
Okay, so how I'm getting this output? Mm. Okay, I think I can like sort the array, so by this way it will be 0, 1, 3, 4, 5, 8, and check and loop over the whole array. Here I have 0. If the start is 0, so I'm gonna continue, because if the start is not 0, the output will always be 0. I mean, if I have an array and this array doesn't continue a zero, so the output will always be zero because it's the
Yeah.
minimum. Yeah. But if I don't
Okay.
have zero, I will go to the next element. If the difference between the two elements is one, I will continue. So 0 and 1, the difference between both of them is 1, so I will continue. Here's the difference between 1 and 3 is 2. The difference between is not 1, so there's an element is not found here. And this element will, I will return it. Like in this case, it will be 2.
Hmm.
Uh,
I get your point. Yeah, I get your point.
is that right? Uh, so in this case, I think the time complexity will be uh, the time complexity is n log n because I'm sorting the array in the beginning, and after that I'm looping over the whole array, so it's n log n in the worst case.
Hmm.
And the space complexity is O of 1 because I'm not using any other data structure, so it's O of 1. Should I
Yeah.
go
Well,
should I go with this solution, or try to implement optimize it?
I guess there might be an optimization you can do, of course, but try and on your way of solving, we can think of the optimal solution.
Okay, and regarding the sorting, I'm gonna use a built-in sorting. Okay.
Okay.
Okay, so in the beginning, I will include algorithm, and then sort. I'm gonna sort the array.
Hmm.
After that, I'm gonna go through the whole array. Uh, okay, I can start from 1. Hmm. I think I can put the condition, which is if the first element is not 0, I can return 0. Is not equal 0, so in this case, return 0.
Hmm.
Otherwise, I will start from 1, the second element, I mean, and it's a 0 based. So if the difference between r of I minus r of I minus 1, like here I have, but there's a case, I
Why
think,
I minus one?
I mean, I'm comparing the current element to the previous element.
But the previous. Okay. Yeah. Okay.
For example, here
Okay.
in this array, if you see the draft in the
You
bottom,
are comparing the 1 to 0.
yeah, here I'm comparing 1 to 0. So the difference is, if the difference is equal 1, so okay, I'm gonna continue. But just a second. I think there is something I wanna handle here before going on implementing the code. Like if there is some elements are repeated. Like if I have 1, if I have 0, 1, 1, 2.
Hmm.
Okay.
You don't have duplicates because the array has unique and non-integers, so there will be
Okay.
no duplicates.
Okay. Uh, okay. So there's no duplicates. So in
Hmm.
this case, I'm comparing if the difference between the current element and the previous element uh, is 1 because there is no duplicates. I will continue. If it is not equal 1, like for example, if it's 3, in this case, I will return r of I minus 1 plus 1. Because, for example, here, the difference between 3 and 1, it is not equal 1. So I'm going to return r of I minus 1, which is 1, plus 1, which is 2. So the output will be 2.
Which is the value of the subtraction.
Ah,
If you
yeah, exactly. Uh, yep. Turn arrow y. Uh, yeah, but there's something like if I have an array like this, so in the beginning I'm comparing 0 to 1, so the difference between both of them is 1, so I'm gonna continue. The difference between 2 and 1 is 1. I'm gonna continue, but here the array, I mean the loop will finish. I have to handle the output. In this case it will be the last element plus 1. For example, in this array I have 0 1 2, the output will be 3. The last element, which is 2 plus 1, which is, so the output will be 3. Okay.
But what if they are all ones and they all exist? Like the input, which is 0 1 2 3.
uh, for example, if it's 0 1 2 3.
Yes, يعني um, if they all have a difference of 1, so it will not go into the condition.
Yep. And in this
So
case
what is your return here?
uh, in this case I will after the loop will finish and I will return the last element plus 1, because it will be the minimum next element. For example, here 0 1 2 3, I'm going through this condition. If the difference between 1 and 0 is not equal 1, in this case it's equal 1, so I'm gonna continue. The difference between 2 and the previous
Uh,
element, it's 1.
but actually, you might have it in this way because it's not. um oh, you already sorted the array. Yeah.
Yeah, here.
Oh, okay, okay. Yeah.
So in the end I will return the arrow of I, not arrow of I, sorry. I will return the last element plus 1, like this. Last element, which is arrow of n minus 1 plus 1, because it will be the minimum next element I can get.
Mm-hmm.
Should I run it now?
Try running. Okay.
Okay,
Out of
let me go
application.
through the code quickly. In the beginning, I'm sorting the array arrow.begin, arrow.end. If arrow of 0 not equal 0, return 0. Okay, and then I'm starting from 1, arrow.size. I think there is no n here, so I can replace n with arrow.size, because I didn't initialize any n.
Oh, okay.
And here if arrow of I minus arrow of I minus 1 not equal 1, I will return
Mm.
arrow of I minus 1 plus 1. I think yeah, I'm gonna run the code. Oh, hash include algorithm. I think this problem it's happening a lot with Pramp when I'm
I don't
using
use C++ actually, so I don't know.
bits std C++ file not found. I'm using sort, and I have to include algorithm.
You can't think of any other data structure that might help you to make the solution more optimal?
Okay. Mm. To get you mean I want to make the term complexity like O of n, not O of n log n?
Yeah.
Great. Okay, I want to optimize the time to be linear using another data structure. So another space. Okay. Okay.
افتكر في الكتاب لو if you read the cracking the coding interview, it actually uses this technique called memorization.
You mean dynamic programming?
No, no,
Heap.
no, no, not dynamic programming. The technique itself is not مش شرط يعني تبقى dynamic programming. It's when you store your current value in another variable,
Yeah,
and this uses more memory but makes the time complexity better.
yeah, yeah. Trade-offs.
Yes.
I'm thinking of using priority queue or heap because this data structure, when I add elements into it, it will be sorted.
Already.
It will be sorted already, and uh, if I use minimum heap, so minimum heap will sort the array. Uh, Minimum heap will sort them in ascending order.
Hmm.
So and then I will loop over this priority queue of the first element, uh, and by this way I can loop over the queue, the priority queue. So it would the time complexity will be O of n, and the space complexity will be O of n. So does it make sense?
It does, yes. Yeah, it makes sense. Yeah. Uh,
Great. So I will use minimum heap. Okay, so I'm gonna code it out here. Uh, okay, I will delete this code or comment it.
هو انا لما بدوس على حاجه من بره بتيجي عندك، يعني انا لو اقدر اكتب انا هنا مثلا.
Oh, okay. I'm gonna use a priority queue, and the type is integer, pq, uh, tq, and I will, mm, yeah, and then I will push all the elements into this priority queue. Okay, I will go through the array, pq dot push. But this way I'm pushing the elements. But there's something important. This priority queue it's a max heap, not minimum heap. I will need to do something like this, and greater. Yeah, by this way it will be a minimum heap to sort them in ascending order, not descending order.
Mm-hmm.
And then I will need to go through the priority queue. While pq dot size, if the size is not equal 0, so I'll go through the elements. Okay. But I think there's some edge cases, uh, because in the end I will like go through the priority queue, so I will pop from it. I will not be able to handle the last element in the priority queue. I mean the maximum element. For example, if I have like 1, 2, 3,
Mm.
and like 0, so sorry, 0, 1, 2, 3, 0, 1, 2, 3. So in the end I will not return anything from the priority queue. I mean while going through the priority queue.
Mm.
So I will, in this case I've already popped everything from the priority queue. I need to make like a variable to access the last element in the priority queue, because and if I, for example here I will have a variable to have 3. In the end I will return this variable plus 1 if I didn't return anything while looping over the priority queue. uh,
Well, if if it's already sorted,
yeah,
so we will always assume that we start from zero, right? Because you said the edge case of if there is not a zero, the minimum will be zero, right?
yeah,
So what if you could use, yeah, like you're doing? a variable which you increment while looping, and this way you might get what you need.
Yeah, I think I got your point. Uh, like making a counter to start from zero,
Yeah,
and the current element, if it is not equal this counter, I will return a counter.
exactly.
Okay, great.
Or if you can search for it in
Priority
in the
queue.
queue itself. So also you need to think of a good data structure that has searching done in a more optimal way.
Okay, okay, that's good. Um, the searching is better in if I use hash map, because
Yeah.
searching complexity is O of 1 for the element itself, but this something. Mm, so in the beginning, I will push all the elements into a hash map,
Mm.
or maybe it could be a hash set because I don't need any variable, or there's no key and variable, so
Exactly. Exactly. Yes.
I will use a hash set and push all the elements into it, and then I have counter of the current element in the set, but hash set will not sort the elements.
But we don't need searching now because we don't need sorting now because we will just search for this because the searching is already done in of one, so it will not cause us a big problem. We'll not use the search. We'll just check if the counter exists in the hash set.
And if it does not exist, I will increase the counter.
Yes.
Okay, that's cool. Thanks. Unordered set, unordered set, and the type is set. Okay, I can say like elements, mm, set, for example. Okay. By this way, I'm inserting all the elements into
Yeah.
the set,
Mm.
and then I can say while true, but I will change this condition later. It will be changed. I'm talking about this condition.
Mm.
Uh, okay. And make counter, if counter, okay, to search there's a built-in function which is count.
Mm.
I'm searching for counter into the set. If it's found, by this way it's found, so I will increase the counter.
Yeah.
Otherwise, uh, I will return the counter. Um, Let me just write some cases here. If I have, for example, 0, 1, 2, 3, but I didn't finish this condition, which I want to change true. Okay. Like when should I finish this loop? If I have 0, 1, 2, 3. Okay, I think I can make a condition here.
Why don't you use a for loop in the array itself? I mean, the hash set has the same size as the array, right?
Yeah.
So yeah,
Okay. Yeah, the condition will be the size of the array, like for example here, something like this. Int n is equal the r dot size, while n minus minus. Uh, Let me see something. For example, if I have 0 and 1, I will loop twice. If elements contain 0, I increase it. So 1, I will increase it.
you need to decrement the array
I think
until
I to increment it by 1. Like make the size of the array plus 1. Because for example, if I have 0 and 1 in the beginning, I will loop for 0. uh, it's already found, so I will increase the counter will be 1. I will search for 1, it's already found, so by this way I will end the loop, but I need to go more one time to search for another element. Yeah, you got it now? And the end I will return like I think I can do it by another way, like the n will equal r of size, but here I will return counter plus 1 or counter. But yeah, but I'm doing it by another way, like, and here I'm returning an empty array if there is no output from this loop. Uh, okay, element set dot insert counter. Yeah, I think this is work. I will run the code. Okay. Oh. If elements dot count. What is the problem? Yeah. Mm-mm.
هي count دي searches for the element or just counts in C++ how it's called.
I think
In Java it's dot contains.
sorry.
In Java it's dot contains, not dot count.
Yeah, but in C++ it's count. I don't know why it is not working. If element unordered set
Maybe you need the brackets of the if.
include. Okay. Yeah, I think because in the beginning of the code I was including set, not unordered set.
Okay.
Run tests. Yeah, it's working.
Great.
Great.
عاش.
حبيبي.
عملتها في الوقت بالظبط كمان يعني نص ساعة بالظبط.
Is there anything that I should optimize in my code or?
I guess no. Using the element set was a trick to take it in or make it in an optimal way of in time.
Yeah.
But it also uses O of m space. So in here, when we see the answer, you'll find that this is already the same that you did. Sorting اهو. Sorting will cost on O of n log n, like you said.
Yeah.
And the efficient solution was to use a set, like you did. So yeah, correct.